Chapter 13, Number 36. A 0.49 kilogram mass attached to a spring undergoes simple harmonic motion with a period of 0.67 seconds. What is the force constant of the spring? So let's identify what we've got here. This is clearly M. And this is clearly the period T. And then what we're looking for is the force constant, which is K. And we'd like to connect these. And luckily, they connect pretty easily. There's something called the period-mass relation for simple harmonic motion. And it says that the period is 2 pi times the square root of m over k. So we just have to solve that. Square both sides. And the reason for doing that, of course, is that we get the square root to go away. And then solve for k, which means bring k up, right? Multiply both sides by k, and divide both sides by t squared. And we end up on one side that k is equal to, on the other side, 4 pi squared m over t squared. 4 pi squared times the 0.49 kilograms over the square of 0.67 seconds, which is 43.09 kilogram per second square. We have only 2 sig figs, so it's really 43, and a kilogram per second squared is the same as a Newton per meter, which is the correct units for K.